All right, here we go with the second half of the Unit 1 review sheet, picking up with number 19. And I decided to do this kind of the same way that they are arranged on your paper. So we're doing 19 and 23 because they're across the top, and then we'll just kind of work our way down. The issue is to match the domain and the range to each function. Now, I have, as a courtesy here, given you a Desmos graph of each one of these so that we've got something to look at. I will have to say that that is probably not such a bad idea. As a matter of fact, you can download Desmos on your phone, for that matter, and use it like a calculator. All right, so when we're looking at the domain here, the domain starts at -3 and goes toward positive infinity. That would be this guy. So he's going there. And then the range starts at 0 and goes toward positive infinity, which would be this guy. Now, when we go over to the other side, our range starts at 2, our domain, our x's, start at 2 and go to infinity, which is not him because he's got a parenthesis there. It is this guy. Be careful of that. There is a definite dot where it starts. And the same thing for the range from 0 to infinity is also going to be D. All right, let's look at the next set. X squared plus 2. Our domain is going to go from negative to positive infinity. So that's going to be A. And our range starts from 2 and goes to infinity, just like this guy was. So we're coming back to him again. Now here, our domain goes on forever, like A, and actually, so does the range. A is the answer for both. Moving on to 21 and 25, negative x squared plus 3. The domain goes forever in both directions, so that is again A. We're going to see a good bit of A with these. But the range goes from positive 3 and goes toward negative infinity. Now, that is not that. That is more like this. From negative infinity to positive 3. And be careful. Negative infinity always goes on the left. Positive infinity always goes on the right. All right, let's see now. The domain here is again A. And the range stops at 3, so it goes from 3 to positive infinity, like this guy. Okay. All right, this I think is the last set of these. So for here, the domain is once again A, goes on forever, but the range goes from 0 to infinity, which is like this, because we can't use the bracket because it never actually touches 0. So it goes here. All right, meanwhile over here, this is actually, you can think of this like this, which means that he is flipping on the y-axis, and then he moves 3 over. Now, why it does that, interesting. It's part of the flipping business, I think. It flips first, and because it's flipped, it's going backwards or something like that. Anyway, If you ever question it, plug it into Desmos and see what it says. All right, so our domain goes from negative infinity and stops at positive 3, which is going to be this guy. And then our range goes from 0 to positive infinity, which is back to this guy. Okay. Now let's switch gears and talk about increasing, decreasing, and positive and negative in terms of intervals. I'm just going to do this. All right, now, as far as reading, you remember with these, I always tell you to watch what y is doing, but write what x is doing. X is starting from negative infinity over on this side, and he gets to 7 in the middle, and he gets to infinity on that side. So as far as our increasing and decreasing, it is decreasing from negative infinity up to 7. Oops. And then it's increasing from 7 to positive infinity. Now, for the positives and negatives, we're going to have to pay attention to these two guys, because they are the places where he crosses the axis. When you think about it, most of the graph is positive except between these 2 points. So the positive is going to start with negative infinity and go up to 5.268. It's going to stop, take a break, come back at 8.732, and go all the way to infinity. Now, meanwhile, the negative is going to take up that gap in the middle, 5.628, all the way up to 8.732. And so it's positive here, then it drops down negative, and then it's positive here again. Okay? All right. Where'd my, there we go. Increase, decrease, positive, negative. All right, as far as, there's not really a negative infinity over here. Everything starts at 0 and then goes to infinity. So as far as my increasing, it starts when x is 0, and it does include the 0 because it is a dot, and it goes to positive infinity. And there is no place that it decreases. Now, likewise, everything is above the x-axis, so there are no negatives. Everything is positive from when x is 0 all the way to infinity. All right. Increasing, decreasing, positive, negative. All right, it is forever increasing. So you're going to go all the way on x's. It is never decreasing. It is always positive from this x to that x, and it is never negative. All right, a cubic model. Increase, decrease, positive, negative. All right, it is always increasing. It actually never stops increasing, so we're going to give it all of the x's, and it never decreases. It is positive from negative 8, and of course you've got your negative infinity here and your positive infinity over here. So it is negative from negative infinity all the way up to negative 8. And then at negative 8, it picks up and it goes to positive infinity with everything positive. All right, now we have the last few weird graphs that we get to name all of the parts of. This is good practice. That presumably goes on forever, but it stops there because there's a dot. So the domain goes from negative 4 to infinity. The range looks like it gets as high as negative 1 and then goes down. So we're actually starting with negative infinity and getting up to negative 1, and there's a bracket there. All right. Local max or min. There is a local, well, actually, there's a whole bunch of local mins. You're probably better off saying that the max is at 2, negative 1. And I got to ask the question, well, for one thing, there's not really a local min here. There's not really a hump. I would ask the question, how many coordinates are there between negative 4 and negative 1? And I'm not just talking integers here. I'm talking fractions, decimals, pi, square root of 3, all that kind of stuff. There's an infinite number in between there. So we can't really pick on one place as a local min. That's going to be our problem. Because there is an unlimited number of ordered pairs that reach down to negative 4 as a local min. Now, an absolute min goes down here with the arrow. All right, decreasing behavior. All right, increasing. Increasing really is happening from negative 1 up to 2. Now, I guess I wish I'd given you more space here. Increasing would be from negative 1 to 2, and decreasing would be from 2 to infinity. Now, as far as the positive and negative behavior, your positive, absolutely none of this. Look at where the x-axis is. It's up here. Every bit of this is existing down where y is negative. So positive has nothing, and negative has everything from where x is negative 4 to infinity. Now, for our x and y intercepts, there are no x-intercepts. There is one y-intercept right here at negative 3. There is end behavior that we can say as x approaches negative 4, y is approaching negative 4. And as x is approaching positive infinity, y is going down to negative infinity. Okay, this guy's a little more interesting. The domain would be all real numbers. For the record, sometimes you'll see it listed that way. That is the set of all real numbers. The range, however, stops at 0, goes from negative infinity up to 0. 0 is included in the answer. Now, for local max, local min, we have 2 local maxes. Negative 2, 0, and 0.25, 0. And a min, a local min, at negative 0.875 negative 1.602. Increasing and decreasing behavior. Well, let's see now. We need to figure out, this is negative infinity, and then it goes up to negative 2, then it goes down to negative 0.9, I'm going to call it to round it, and then it goes up to 0.25, and then it goes down toward infinity. So we've got a couple of, I'll tell you what, let's do it this way.